All right, we have a new title here, True Length of a Line, Mung's Procedure. And by the way, previous I was saying Munget's procedure. Somebody told me it's Mung's procedure in the notes under a YouTube video. Uh, and then well, anyway, I'm going to use Mung's. I believe this person. Anyway, uh, skewed views, true length of a line, point view. Those are three types of a line you see I've listed here on the left. And on the right side, this is the end of the Mung's Procedure 2 video and that I put up. And these are three skewed views of a line. And the question is, how do we know that? How do we know these are skewed views? And how do we know they are not true length? They are certainly not point views. A point view is just going to be a single point. We'll see that in a future video, a future lesson. We know we have true length. If I were to allow me to just kind of quickly show what a true length, how we know we'd have true length, I'm going to kind of just freehand this. If I had seen that AB, let's call this again the front elevation and profile and plan views. If AB looked like this, what's the difference between that AB and the one I have in the front elevation on the right? The difference is it's parallel. I'm trying to draw it that way. Parallel to the folding line. And if that's the case, then I would know that this view, AB up here, would be the true length. I'm going to just, as I say, I'm just freehanding this. All these things project, they're supposed to anyway. I guess it, well, let me see if I can fudge that a little bit more, get that in there. Anyway, so because this is parallel, there's a parallel here. AB is parallel to the folding line. That makes, on the adjacent side, that makes AB true length. That's the case there. That's what would have happened. We don't have that situation on the right. So this is just a little thought cloud thing. That's how you know you have true length when your adjacent view is parallel to the folding line. Just accept that as a rule right now. And so I need a view where I have AB as a parallel to a folding line. So what I'm going to do, our challenge, this is our challenge. In fact, let me make it a clear goal here. This is our goal, find the true length of line segment AB. So that's our goal, find the true length. We know we don't have it. We have three skewed views of AB. What I'm going to do, first step, I'm going to take this view. I have some room here. I can do this. I have some room below the profile, left profile elevation view. I have all this noise down here. Let's get rid of that. Okay. All right. So I'm going to draw a folding line in green that is parallel to AB. I don't have to go too far away. I'm doing this visually as best I can to get a parallel. So you don't see me lining up my ruler right now, and that's unfortunate. But I'm trying to get it as parallel as I can without using I'm not using proper tools to do that. Measuring, actually, I guess, I'd have a T-square up here and I'd measure a distance here, making sure. I'm just teaching the concept right now. And so assume that really truly is parallel. And the next step, so you got a parallel folding line. Let's label it immediately as I say, auxiliary view 1. It's not one of our principal views. Our principal views are the front elevation, profile, and plan view. Okay, so I'm going to do this, and if you're teaching this in class, and it's even if you're a student, it's good to teach it to somebody else. That's how you really learn it. Trying to get a good perpendicular projection line. It's at a perpendicular angle to the folding line. I'm not drawing it straight down this way. If you're teaching this, you'll see some of your students do that. Maybe they'll do it with one of them, and then this one will be right. Projection line needs to be perpendicular to the folding line. And then, of course, they need to be parallel to each other. So there's my noisy, if I clean up some of this noise here, my projection line. Oh, I see it clean up there. Okay, so now that's great. Okay, so we have some projection lines that are perpendicular to the folding line. And we look along this projection line from the point A into the auxiliary view. Our new point's going to go in here somewhere. It's not going to go back here. Our new point's going to go somewhere in the new view. Question is, should it be close to the folding line? Should it be somewhere in here? Should it be far away from the folding line? How do you know where to put A on this folding line? The answer is, if from the new view in which you're trying to put your new point for A, you skip one folding line and you skip two folding lines. You always skip two folding lines. And here they are. That puts me into the front elevation view. And I see the distance is going to be from that folding line, the folding line all the way to A. I'm going to mark it in red here with the little indicator here. This distance is, I'm going to call D1. I'm going to measure that distance with my architect scale. I see that it's, is it just a quarter? It's a quarter over a full inch, 1 1/4 inch. And so I'm going to take that 1 1/4 inch. I'm going to mark it right here. There it is. That is a copy of that same D1 distance. Where did I grab it? I skipped two folding lines, and that's where I got it. And I'm going to mark it in black down here. That's how I like to put the points in the black. Is B going to be close or far? It's going to be, we skip two folding lines, and we're going to see it right here. That's the second distance. I'm calling it D sub 2. It looks, if I just looking at it, it looks like something over a quarter inch. What is it exactly? It is a 1/16 less than a half. In other words, 7/16 of an inch in. So I'm going to go 7/16 in, which is right here. That is a copy of distance 2. Distance 2 copied right there. And so now, and again, I should be labeling my points immediately. And I'm going to do the best I can on the tablet screen with a ruler anchored by my thumb at one side of the screen to get, I did all right there. That's a little shaky. That I'm going to immediately label as true length. How do I know it's true length? Because when I look across the folding line, AB is parallel to that folding line. That's how you get true length of a line. There's the full picture, but true length is right down there. Oh, and what you would do is if quarter inch, let's say a quarter inch, you have a quarter inch scale where a quarter inch equals a foot, and I'm measuring this, so I'm measuring 1 9/16 inch. Tell my students not to write their fractions like that, and here I am doing it. 1 9/16 inch, and so that would correspond to, in real life, if that were the scale, a quarter inch equals a foot, 1 9/16 feet. And so that's, I'm not sure that's off the screen, so I'm going to bring that back here so we can make sure everybody sees that. Okay, so that's it. The other thing to notice, though, about true length, that is the longest version of the line. If I measure this, it kind of looks like the plan view up there at the upper right. Looks like it's about the same size, but it's not. It's like 1 1/4 inches, and you come down here, it's 1 9/16. This guy looks like he's somewhat close to that length, but no, this is longer. True length line will always be the longest line, but that's not the only criteria. Remember, this used to be the longest line, and it wasn't true length. True length has to, if we look across the folding line, you have to have a parallel version of that same line, and that's what makes that true length. Okay, I'm telling you to accept that as a rule. Because in class I can show it easier when I'm holding a ruler in front of the class and showing what it would look like if the ruler were parallel to their plane of vision and all of that. But anyway, that's how true length of a line works.